Welcome to this webinar on the E3 process. My name is Royal Smith, and I will be presenting today alongside with Jerry Giza from the Northeastern Pennsylvania Industrial Resources Center. I'll be referring to them as NEPERC for the rest of this program. We've also had some slides provided by Keith Goosen, who is the director of the Mid-Atlantic Industrial Assessment Center in the University of Delaware. A couple quick notes before we get started. If you have any difficulty with hearing the webinar, please try the test audio settings function in Zoom. And if that doesn't work and there's further problems, you can let me know via the chat pod, although I may not be able to get back to you as quickly as possible. We're also going to wait till the end to answer any specific questions, but you can add them into the chat pad as we go through, and then at the end I'll gather them all up together. Our presentation will probably be about 55 minutes long with about 5 minutes for Q&A, but we'll take as long as needed for the questions and answers. And then this webinar will be recorded and it will be uploaded to PennTAP's website a few days afterwards. So the intent of this webinar is to give you a background on the E3 process, as well as review some case studies. So the first thing we're going to talk about is Jerry Giza's group. It's the Northeastern Pennsylvania Industrial Resource Center, and the map on the slide is showing their coverage area in the northeast part of the state in orange. And NEPERC, as they're known, specializes in helping businesses grow through continuous improvement, effective sales and marketing strategies, and training. NEPERC can also help with industry certifications and leadership development. NEPERC offers experts in continuous improvement training and audits, and I personally have seen firsthand how well they do with those audits and figuring out opportunities and places to eliminate waste. If you're not within NEPERC's region, I wanted you to be aware that there are 7 industrial resource centers throughout the state of Pennsylvania, and there'll be one within your range that you can reach out to. If you want help finding yours, please let me know. And now for Penn Tap, we're the Pennsylvania Technical Assistance Program. We go by Penn Tap, and we're part of Penn State's Vice President of Research. And we're a statewide technical assistance program charged with supporting Pennsylvania businesses and anchor institutions. We mainly focus on manufacturers, municipalities, entrepreneurs, and economic development agencies. As a department within Penn State, PennTAP offers unique access to an abundance of resources from one of the premier universities in the country, including faculty, staff, and students. PennTAP can provide clients with assistance from a rich network of government entities and private organizations. PennTAP focuses on helping Pennsylvania's businesses through 2 primary areas of expertise: energy and environmental services and innovation services. Since being founded in 1965, we have delivered services and solutions to many Pennsylvania businesses and professionals, creating a legacy of documented environmental impact within the state and positive returns on investments to our funding partners. In the past 10 years, PennTAP has worked with more than 3,700 organizations who have in turn reported approximately $300 million in economic benefits, and the job creation or retention of more than 4,000 Pennsylvania jobs. Our mission: to empower, engage, empower, and educate Pennsylvania organizations through technical assistance and Penn State expertise and resources. So today we're going to be talking about the E3 program. E3 stands for Economy, Energy, and Environment. The goal is to identify opportunities to reduce costs, reduce energy, and eliminate wastes at the same time. The E3 program is developed with multiple federal and state agencies joining together. The 2 notable agencies are the United States Environmental Protection Agency, also known as the US EPA, and the National Institute of Standards and Technology, also known as NIST. The US EPA has been funding PennTAP to complete a series of E3 events for the past couple years. The idea behind the program is to bring together experts in continuous improvement, energy audits, and environmental waste assessments together into one team. Using the combined knowledge of these experts, the team is then able to identify opportunities no single member would be able to on their own. So one common question is, what would the ideal facility be? And the ideal facility is a large user of electricity with a complex process line. The facility owner would also be committed to continuous improvement at the site. When we first visit a site, the team would start by picking an area of the facility to focus on. It could be a process line, a common process step, or a section of the building. The goal is to pick a narrow focus that allows the group to fully explore that focus area. We'd be looking at the different improvement steps in just that specific area, but the steps we identify there may be applicable to another similar process within the facility. In order to illustrate the E3 process, here's a simplified example of a potato chip manufacturer on the next few slides. The slides are designed to show how each audit would work independently, with the final slide showing a combined approach. In using the chip manufacturer as an example, we'd start with storing the raw material, the potatoes. Then the potatoes would travel via conveyor belt to a cutter, which would slice and resize the potatoes appropriately. Then those sliced potatoes would go into the fryer. Then they'd be sent to packaging and then a warehouse. So this same basic process we're going to talk about from 3 different points of view. If we came in looking at the economy piece, or the continuous improvement piece, we'd start asking questions along the lines of how many employees are needed for each step, how much time does an employee spend there, how much time is required to change the equipment between product lines, how often does preventative maintenance occur, how often does unplanned maintenance occur. And in the end, the continuous improvement expert would like to figure out why the process line is not always in operation. During a general energy assessment, the focus would be on the major uses of electricity. The auditor would focus on the lighting for upgrades. They'd review the compressed air system for leaks. They'd determine the efficiency of the comfort heating system and the process heating system, and take a look at the building envelope. The process sort of plays a secondary role when developing the savings opportunity. But for example, the process heater would be heating the oil for the fryer, so we'd be saving money at the process step, but it wouldn't be the main focus area. And generally, it'd be looking at more of the ancillary equipment, so we'd be focused on a $5,000 lighting project upgrade versus $100,000 for a new process oven. Just different scopes. So during this assessment, we'd be asking questions along the lines of how much natural gas is used by the boiler, what are the controls for the heating system, and how many leaks are in the compressed air system. For an environmental waste view, we'd be focused mainly on the waste that's coming out of each step. Each waste will be reviewed as kind of a separate hazard with a value of the waste material determined, and then trying to figure out the ability to reuse it. While the raw materials entering do play a role, the focus is generally more on the waste output of each step. There may be a part of discussing about reusing, recycling material, or using a different material to reduce waste, but really the first start is focusing on that bottom output waste. During an assessment like this, we'd be asking questions along the lines of how much waste is generated by each step? Where does the waste go? Can the waste be reused? And what changes could be made to reduce the step? So then if we're trying to pull all 3 of those together, you get a better full sense of what's going on at the facility. With this combined approach, it's much easier to see how the energy usage relates to the manufacturing process and how that relates independently to the environmental waste process. You're now able to get a better estimate of the energy savings, the process step savings, and the environmental waste savings from one change. So a question during this kind of phase of the operation, this this type of review would be, if we change the cutter blade, is it possible we could increase productivity, reduce waste from that step, and save energy at the same time? Could have, would improved best maintenance management practices allow for less water usage to be done during the changeover times? Or something like, can streamlining the equipment help reduce the hours of operation, lowering both overtime pay and utility costs? So it's a different approach that allows you to find more information throughout. So now we're going to go a little separate and discuss the energy and environmental savings as one piece and the continuous improvement as one piece. But please note that these will be linked up when we're doing the assessment. This is more for getting people to be able to present separately. So I'll be presenting the energy and environmental savings piece, and then we'll have Jerry Giza come in for the continuous improvement piece. At the beginning of the E3 process, we'll talk about utilities and wastes that are used throughout the facility. Most of the common areas would be looking at boilers and ovens, which are very common throughout food manufacturing. If your site requires any sort of cooking, there's going to be a boiler or oven within the site. And there are also ways we can look at the boiler and heat system to see how it's losing heat while it's being distributed throughout the facility. Compressed air is common throughout all manufacturing. It is common for leaks to occur within the compressed air system, and generally finding and repairing leaks are a good, quick, inexpensive way to save energy. We'll also be looking at ways to recoup wastes from the overall processing, and there's a couple different common wastes that are included with heat waste, water waste, and food waste. Waste heat happens when heat that could be used for a different purpose is sent directly to the atmosphere. During an E3 assessment, we'll figure out where the waste heat is occurring and where it could be used. The last piece of that puzzle is trying to figure out how we can go from where the heat is being wasted to where it can be used and figure out the step in between there to reuse it. For water usage, we'll be figuring out where water is lost in the whole process step. We will pretty much ignore the water that gets sent out as the product, since that is usually a big key piece of food manufacturing, but we'll focus on where water is going down the drain to the wastewater treatment system, and we'll focus on those areas to improve. And then for food waste, we usually see that it's the cleaning process that causes the problem, that's really the biggest huge source of waste. And we go into this process with knowing that cleaning is a key piece to ensure food safety. We're not going to tell you at all to stop cleaning or do anything like that, but our goal will be to ensure that you meet those sanitary standards and you clean it properly and safely, but using the minimum amount of waste needed. So there's a little bit of a give and take there to ensure that everything is done by the book, by all rules, to make sure there's no cross-contamination, but you're not using 20 gallons of water when 10 would do well. So while on site, we'd also focus on gathering important process information. We'd want to ask questions about how the equipment operates, where things are located, and their hours of operations. We'll also be monitoring some of the equipment. After that site visit, we'll take all that information and we'll develop the cost savings with any opportunities we see, as well as creating the project costs and evaluating any of the applicable grants and rebates within the system. So we'd gather up all that data to figure out how you can save money in this step. So then, as another step in the process, we'd also be trying to create a pie chart for the energy usage at the system. The information will be based on the equipment there, discussions with the site, and data loggers if we can add them to the equipment. This data is really key in figuring out the broader impacts of the energy audit at the site, the E3 process at the site. I think step one is that it helps us to focus on which areas have the potential for bigger energy savings. Within this case, you can see that the orange, that's the cutter, has significantly more usage than the raw material processing. So that's an area we'd want to focus on. But the second thing this does is it allows PennTAP to have a better link to the continuous improvement opportunities we'll be discussing later. So this data will show us how much energy is being used in comparison to how many process steps are being used. And that's a very important piece in gathering everything together. So we'll do the same approach when it comes to waste. And in most cases, the waste is centralized within 2 to 3 major steps at the facility. And it's important to keep these steps in mind when we're discussing the continuous improvement opportunities. And the big key there is we don't want to do something by accident that makes the waste worse while we're trying to improve everything overall. For each E3 assessment, PennTAP asks that we can bring a group of students from Penn State in to do part of the energy audit. The students are from the energy engineering major, they're seniors, and the plan here is to get them out of the classroom and to experience manufacturing before they leave. The group of students would be 4 to 6 students and then 2 PennTAP advisors, and we'd be there to help make sure the students don't do anything that's unsafe and they're planned properly. Since many of the students have never been to an industrial site before, we request a 30-minute to hour-long tour, and that really depends on the size of your operation. The tour in this case would be focused on that industrial process step by step, and then we take time afterwards to work on the energy audit portion. Really, the key with the tour is that we want to allow the students to be able to be comfortable where they're working, where the tour lets them get used to some of the hazards beforehand, to be aware that, oh, this is where the fork trucks are driving through, or, oh, this section has very hot metal, let's not go anywhere near that section. It also gives them more background on how an industrial process works for their education. And then afterwards, we'd work with them on gathering the important information for the energy audit. PennTAP would be providing the personal protective equipment. So each of the students are required to buy their own steel-toed boots and bring them with us, but then PennTAP would be providing things like the safety glasses, hard hats, and high visibility vests. So next we're going to have Jerry Giza present. Jerry, I'm going to unmute you right now. So you should be allowed to talk at this point if you don't mind Jerry, if you don't mind unmuting yourself, you should be able to speak.
Good afternoon. Can you hear me?
Yes, perfect. And I will move the slides for you.
Wonderful. Well, good afternoon, everyone. As Royal said, this is going to be the continuous improvement portion of this whole program. And what I've done is kind of laid out step by step how we typically approach a project for continuous improvement as part of the E3 program. And as well, when we get a little later into this, I'll be discussing a case study that we had looked at just so that you could see some actual examples of how that works. So the first part of this is planning and an assessment based on observations and discussions. And what we do like to do is spend a fair amount of time with the management, by a fair amount of time, maybe a half hour to an hour, to truly understand what their mission and strategy for growth is, what are their product families, and hopefully get a walkthrough to observe how they do things today. After we do that, we're going to ask to develop a charter. And that is basically formulating what is your plan for growth and how are you addressing and what are your critical business issues. And part of the reason for doing both of these items is for us to get a little bit of a high-level view of your company and how you want to run your business. And then secondly, to help identify how we could move forward, specifically usually using a value stream mapping activity, And I'm going to get into a little bit of what a value stream map is for those people who don't know what it is. And then secondly, using that value stream map to identify the opportunities for improvement, and then ultimately to develop an implementation plan for who is going to do what by what, when, to improve or improve the productivity of the process that we're looking at. If you could flip to the next slide. There we go. So the first, in this case study, mission and strategy, this is an example of what we uncovered when we spoke to the company management, and that is that they were actually measuring their performance with two metrics, one considered total effectiveness and the other running effectiveness. And what their mission or what they wanted to achieve was to improve their TE and RE performance while decreasing waste and reducing utility consumption. They had a specific desire to try to reduce water as well, because they as Royal had just mentioned, it's an integral part of many food manufacturers. So they had a strategy for growth. They had already identified a larger market that they could service. And what they wanted to do was to increase this product A that they were making to make it more profitable and make it more efficiently. And they were willing at that point up front to say if they had to invest in some equipment modifications, they were willing to do that. Next slide. So the background for this company was it produced 4 product families, and as they introduced the new product A to their building or to their facility, they recognized that it was not performing as effectively as the other 3. So what they wanted to do was focus on that one product family, product A, to map it and to identify what were the shortcomings or what were the wastes being produced in that process. Next slide. Critical business issues that they had already identified was to reduce downtime, reduce the waste, and the waste was not only the wasted materials, but also some of the activities that they were doing. Reduce utility consumption and water consumption, and effectively increase the total effective performance and their run effective performance. Typically, when we work with companies, we do like to ask them how they specifically are measuring performance, because we really don't want to have to create a new measurement technique. We prefer using measuring techniques that are already in place, because our purpose isn't to add any more administrative work to calculating the performance. If for whatever reason a performance metric doesn't exist, then we probably will help to establish what that is and prior to us beginning to change anything in the process. Next. After we've done that, we identify what are the obstacles to improvement. And quite often there are obstacles that people maybe hadn't thought of. In this case, we had limited floor space for expansion, so we weren't going to expand, and to increase our capacity, we weren't going to consume any more floor space. We had to recognize the union employees and management and begin to train and educate them in what are the lean principles and what is value stream mapping and how is it done. Basically, the value stream map gives everybody on the team a common understanding of what the existing process steps are. And let me just backslide a little bit to the team. Typically, the team is going to be a combination of operators or hourly people from the process owner, whether that's a supervisor or a lead person, and then finally management representation, so that we have a cross-sectional team that is willing to open their eyes and they're a little bit open-minded, so that they can gain this common understanding of what is the existing process. quite often we find everybody has a different opinion of what the process is. And once it's mapped, it brings everyone together so you all have the same understanding of what that process is. And we had to identify the weaknesses in the present process, and then lastly, identify if there was any additional equipment needed. And the only way it is acceptable is if it, of course, has a good return on investment. We don't want to just throw money at it. Next slide. Quick agenda. Day one, observe and draw the existing state. Day two is to draw what we believe could be the future state as we make improvements. And then day three is to really document who's going to do what by when to achieve those things to get us to that future state. We typically like to limit that to a 90-day improvement plan. Because in today's world, business changes so rapidly every quarter. What we're interested in is, can we get some immediate improvements, but also recognize things that may be on the list that are going to take longer than 90 days, but not make them part of that actual implementation plan. And what's very important is to continually monitor that plan after you've established it to make sure those actions and those improvements are actually happening. Next slide. Implementation objectives, introduce it in a hands-on manner, and I'm going to talk a little bit more about that. But that team that I just described will actually go out on the floor and gather the information and walk the process. We typically do not gather a whole lot of data from a database or information from a database. We typically observe and map what we've observed as a picture of what was happening that day. There's a little bit of training so that people understand what are the wastes, what are the problems, how do we determine root cause, how do we put an action plan together. So all of those things are covered in the upfront training. Jim Womack here, who was the, many people call him the father of lean as far as the US is concerned. His quote was, whenever there is a product or a service for a customer, there is a value stream. The challenge lies in seeing it. And quite often what we found in our cross-sectional teams is that each perspective is a little different. So the value stream that they see is a little different. And that's why it's important to get that cross-sectional team together to work on this. Next slide. For those of you who haven't experienced a value stream, this is a very simple explanation, but it really begins when the customer gives you an order. And what are all the major steps that has to go through before you can actually get that product back to the customer? Quite often, this process is a little bit truncated, and quite often we found with the E3 projects that many people want to start at the material supply and end with the customer shipment and not evaluate what's happening in their offices as far as how they're handling orders. The important part of this is whether it starts at the customer order or whether it starts at the material supply part of this, what we map is going to include everything that happens in reality rather than in theory. So we will observe and monitor everything that happens from that step to the end. We will walk that process. Next slide. It begins with a product family, and we'll identify what is the product family that you want to focus on. And as Royal was saying, sometimes that could be focused on one section of the building and the product that's being made in that section of the building. Or it could be that you focus on a product going through one specific process line. Whatever the case is, we do want to identify what that product family is because that's exactly what we want to map. Next slide. This looks a little busy, but I thought I wanted to show it to you. Basically, this is what the charter looks like, where we will gather the information, and it's typically a 3-day event, and that could be 3 consecutive days or 1 day a week. We've done them in various ways. But we identify what is the target area. In other words, what is the product family? Secondly, what is the background? Do we know anything about what is happening, and are there any specific issues that we need to address? What is the scope of the product? And that is basically, where do we begin the map and where do we end the map? As I said, sometimes it's the full enterprise, other times it's beginning where we receive materials and where we're and ends at the shipping dock. We try to identify what are the major steps that are happening in this area. And then finally, the current condition. What is known? From a management review standpoint, what do we know, or what do we believe we know about the process as it stands right now? And we do this because we want people to put a little thought into what we're looking at and why we're looking at it. And that current condition becomes very important as far as a perception of what management, at least at that point, thinks is happening in that area. Next slide. Then we go ask management to agree on what is the target improvement, what is the vision of success. And in this case, it was to increase that total effective performance by decreasing waste and reducing utility consumption with a special focus on water reduction. That was our focus. And although we just simply say increase TE performance, I'll talk a little bit more about that when we get to critical success factors. Stakeholders are basically who's supplying the raw materials, who owns the process, who is going to be on this team. In this case, we had some people from the floor engineering as well as the production managers and maintenance engineers. And then finally, who is the customer? Where are you sending it to? Our process ended at the distribution centers. Critical success factors are sometimes very elusive for people to try to identify. And there is no one set rule, as the only thing we ask is that people try to identify some financial metrics, some metrics which affect customer, which is typically quality or on-time delivery, some for the process, and that is overall effectiveness or productivity is usually there. And then for the coworkers, we found safety issues. We found non-standard activities going on, so putting standard work in place. Or in this case, it was how many of the workers were actually following the standard work that did exist. And we ask, where are you at today? And then finally, what is the target? What do you believe is realistic for you to achieve in a 90-day period? And then we establish what that target is up front, just in case as we're reviewing this with everyone, if there needs to be any revisions or reality checks. Next slide. Next is to draw the current state. And basically that is all of the material and information flows that impact this particular value stream. We walk the flow, we get actual times of how long it takes to process at each process step. And we rarely will go in and look for engineering standard times and use those. We typically want to see actually what's happening and how long does it take to process it. And this becomes our foundation for reviewing the current state so that we could reliably start predicting what a future state could look like. Next slide. This slide is just in there just to illustrate that we do not do this in a conference room. Typically, we go out on the floor and walk the process start to finish to gather and observe that data. Next slide. Excuse me. Once we gather the data, we usually put it on a map on the wall, which in this case, it should be a pencil and paper exercise. We have experimented with using electronic mapping and found that it's much more efficient and actually much more clear to do it as a pencil and paper exercise where people can actually go up and kind of move the process steps around and identify where they see issues. Wherever you see those yellow post-its posted above a process step, that's typically an issue or a problem at that point in the process that is, for some reason, slowing the process down, or somebody is doing extra work that they shouldn't have to do. Or it could be a quality or a safety issue at that particular point. Next slide. Once we've identified in paper and pencil what is the current state, then we're going to move on to what do we believe our future state would look like. And that basically is what are the issues, what are the weaknesses, what are the problems, and if we can put actions in to solve those, what does that future state begin looking like? Next slide. And at that point, we will put it into an electronic format. And part of the reason for putting it into an electronic format is on the left side of this is a box listing all of the assumptions and all of the conclusions of where we're at, where we believe the future state could be, and what is that improvement. Secondly, by putting this software happens to be Excel, putting it in Excel allows us to use this as a calculator so that as we change process step times or wastes that are happening at that process step, we can easily add up to see what the overall impact is, and actually it converts into one big calculator so that as you start changing values and doing what if analysis, those what ifs translate into what is going to be the actual impact of what you're doing. Along the bottom of that value stream map, you'll see a stepped line. And what the step line is number one, measuring the touch time, or the value add process time as we call it. And then at the upper portion of that step line, it's measuring the lead time. And that is how long does it take from it enters your facility until it exits your facility. At each of those process steps, there's data as far as how many operators, what is the cycle time, what is the lead time, what is the first pass yield, which is what is the quality rate at that line, and some other the distances that are traveled. There is no set rule. We put into those process steps whatever is important to your particular business. But on the bottom of that process, each process step, you'll notice there's some areas there for energy consumption, for water use, for material use, so that we could begin to quantify where are the wastes primarily located at which process step. So that helps in the analysis. If you look at the red and the blue bursts, we call them bursts, that are on there, they're basically the notes that are addressing the post-it notes from the previous slide. And we're trying to identify what are the actions we're going to take to resolve some of those issues. And what they are representing are actions that this particular company wanted to take at each of those areas to improve this overall process. So this begins to electronically let them know what their future state process will look like. Next slide. Can an implementation action plan and it create that implementation plan? Next slide. The way we do this is to take each of those bursts that were on the value stream map. Typically they're called Kaizen bursts. What we do is translate those into specific actions. But what we try to do as we're creating those actions is truly understand what was the obstacle we were trying to improve or overcome, who is going to head up this effort, when do they start, when is the projected fit completion date, and then finally, and most importantly, what is the expected improvement? And we need to quantify that. If you just look at action item number one, which was test new set points for improved efficiency, if we were able to actually more accurately predict what those set points should be, the ultimate improvement was going to be reducing downtime by 2%, which was going to directly translate into a 2% improvement in the total efficiency. That's a big deal. So that we need to identify not only what we are doing, but what do we believe it's going to be as far as an expected improvement. After the 90 days, you'll notice I have a 4-month review on here, because typically some things cannot start in the first month. They'll start in the second month, in which case they'll be finished in the 4th month, still within the 90 days of activity for that item. But it's important in understanding, when you've completed it, did it actually do what you thought it was going to do? And then secondly, how are we going to make sure we don't backslide? How do we make sure that that is not going to, in 2 months, go back to where it was before we started? So what are the sustainment actions? Sometimes it's standard work, sometimes it's procedural. And secondly, what did we learn? Did we actually achieve that 2%, or did we only get to 1.5%? Or did we get to 3%? What did we actually learn? Next slide. Keys to success. Each of these value streams should have a value stream manager. Someone should be overseeing this and taking the responsibility to make sure that all of these improvements go into place, and if there's any barriers that get thrown up, that they help remove those barriers. Install realistic performance measures, create an atmosphere of experimentation. We need to recognize that as we do this in that 3-day period, we are doing our best, but we may also be making an error. We may be making an assumption that's incorrect somewhere, so that we've put an action item in that's not going to give us the result we want. It doesn't mean we shouldn't experiment and try to get there. What it means is we have to have a safety net so that we don't adversely impact production or adversely impact a customer. And we want to experiment, we want to improve, but we don't want to take unnecessary risks. And finally, unyielding leadership with lean enterprise as part of the strategic vision. It's important because there's some specific principles that are in play here. Most importantly is respect for the people who are doing the work. And we'll talk more about that on another time, but that's important to the success of this. Next slide. In this particular case, these are some of the results we saw. On the left, you'll see some numbers based on what were the actual electrical uses and electrical costs. And on the right chart, we're looking at what were some of the things that happened after a 30-day status review. In this case, we were able to do that 30-day status review. And while our target, for example, for run effectiveness was 90%, we had found we had already improved it from 80 to 85% in the 30-day period based on their numbers that they were tracking. Same pretty much for total effectiveness. Quality was already at 100% attainment, so we retained it at 100% retainment. Productivity, which was measured in product per period, had actually increased 20%. So that means that they were producing 20% more product per day, and they did have that market and the outlet for that product. And as far as number of people following procedures, our target was 100%, and we were pretty close to 95% at this point of everybody being cross-trained and following the standard work that had been created. Next slide.
Hey, Jerry, that was done with your slides. Thank you so much.
Thank you, sir.
I'm going to put you on mute, but I'll unmute you in a little bit for our section on questions.
Okay, fine.
So now we're going to go over a case study that was provided by Keith Goosen, who's with the University of Delaware. He has done work with about a dozen food processors in the past year, and he wanted to share some of the notable work he's found. It's kind of like the common opportunities he's been finding within this work. So these are his slides. He's unfortunately teaching a class at the moment, so he asked me to go through them to help out, so he didn't have to cancel class. One of the first things he's noticed are that evaporators are exceptionally common throughout food manufacturers. If you think about everything that needs to be refrigerated, whether it's the raw material or the final product, they're just commonly found throughout the area. You can see within the picture he's provided, at the top end of the hall, there's the evaporator. It basically looks like a box with 3 large fans around it. But one of the things he's been working on is noting that those fans are always in operation, but that you might be able to turn those off for saving, have them run only when they need to, and work with auxiliary fans that help move that cold air throughout the facility. So instead of having the 2 fans at the top of the ceiling on each hallway kind of push cold air into the middle where they meet, and then when they meet, push down, this would be pushing the air all around continuously, so you'd avoid hot spots in different areas. And then in theory, if you're reducing those hot spots and keeping everything more consistently cold, you'd then be able to raise the temperature of the room more reliably. So you're not over freezing certain areas, you're keeping everything in the same temperature. Then he's also been working with some fermentation tanks to see, does it make sense to be cooling the room in addition to the tank? And his work so far with 2 microbreweries is that it's become apparent that cooling around the air around the tanks really helps to reduce energy at cooling the tank. He has some real numbers in here, but basically what you're able to do then is kind of raise the temperature of that chiller tank and not have as much food spoilage and still allow fermentation to continue. He was also at a Shellfish Processor that was having trouble with water consumption. And they found that there was a water consumption of around 20 million gallons of water was occurring due to overflow within their process. And they were taking a look at fixing a better cooling system, and they were focused on there's water savings and cost savings there. But their real concern there was that the overflow system was causing extra bacteria growth. So if they could reduce this with a cooling system, that it would help out with that bacteria growth. So they figured out a way to help reduce the water usage throughout. They wanted to install a clear well in addition. That would be a buried sump to hold the city water before pushing it into this canal system. And that would help to pre-cool the water before it went in. One of the troubles was it was very hot water in the summer that was causing part of this problem. And they're thinking they might be able to save around 6 million gallons of water per year through that system. As a final case study from Keith, he went to a large brewery to take a look at their CO2 system. So they were creating the CO2 to be able to put within the beer, and they were processing 280,000 barrels of beer per year, and they found that it was possible to collect 3,560 pounds per year of CO2. They found that the CO2 purchase cost was around 8 cents per pound, and that led to a savings of almost $285,000 per year. They had a payback period within that system of about 3 years, and it was a CO2 recovery system. Using a rough 5-year estimate that the system would work, they'd save about $1.5 million per year with that system. And then on that note, the case studies are completed, and now I'm going to go over some of the implementation data that PennTAP has had in the past 2 years of doing E3 audits. So during 2017 and 2018, PennTAP has completed 4 E3 events. 2 have been working in the northwestern section of the state, and 2 have been in the northeastern section with NEPERC and Jerry. From the 4 assessments, we've seen savings of $200,000 per year already in cost savings, and a large part of this is 275 kilowatt hours per year of electricity have been saved from those projects. In addition, we were able to help one of the facilities get over $100,000 in grant funding to buy new equipment. So that was all part of this assessment. Is with new equipment, you'd be able to rearrange your facility and we'll help you get grants. Further, we're still working with those sites to gather more implementation data due to just some of the timeframes of the improvements. It can take a longer time. Jerry had mentioned that 90-day window. A lot of times we find something within that 90-day window, it moves forward and gets implemented, but then we find some bigger projects that will take more time. So we're still following up with sites. We've also worked with 2 other companies in 2019 so far that their implementation is currently ongoing right now. So it's a little bit too soon for us to gather any data from them, but one of them was the case study Jerry showed, where even within a 30-day period, they had already started showing some of their improvements. We're just waiting for those improvements to get further along before we capture the data. Now I want to review a little bit of Penn Tap and some events that are coming up. So the Penn Tap Energy and Environment team, our successes from 2018 are on the screen. The $2.8 million in economic benefit is really where I like to show people we're able to help companies save money quickly, and engaging over 150 students is a great way for us to work within the university. We completed 53 assessments during that time frame and helped companies save $1.5 million kilowatt hours of electricity. For our innovation team, we helped save 34 jobs, saved or created. We worked with over 300 students in the programs. We ran a program called InkU that helped give out $30,000 in grants to student entrepreneurs. We helped sell 46 learning factory projects, and these are senior capstone projects in engineering. And they help companies solve engineering design problems that the company might not originally be able to do. And then the innovation team had $2.1 million in economic benefits. So we mentioned our services briefly, but PennTAP under the energy sector can do the E3 assessments we reviewed. We also work on energy audits for facilities that aren't quite ready to go through the lean manufacturing process. Again, we work on energy management systems, which is taking each piece of your operation and working it through procedures to make sure you're saving energy as much as possible. And then we're also running a conference this March that's on building retuning, which are low cost, no cost ways to improve energy at your site. Our innovation team works with product and process improvements. The Learning Factor, as I mentioned, was a capstone design course, and then we help student entrepreneurs move their companies forward. So PennTAP has a couple events coming up. You can see our website for more information about these 2 webinars. We'll be talking about the Pennsylvania Innovation Program, as well as entrepreneurship ecosystem at Penn State in October and November, respectively. Then I also wanted to mention that NEPERC is hosting a Manufacturers Day event at the Scranton Hilton Conference Center on October 4th. If you're interested in going, please see NEPERC's website for more information. The Manufacturing Day events are generally great events to help get a sense of what's going on with manufacturing within our region. So I highly recommend NEPERC's event if you're in the Scranton area. And then finally, we're on to our contact information. If there are any questions in the chat pad, I'll bring them up in just a moment. But if you have any questions later at a time, you can feel free to email any of us directly. I think we're all very appreciative that you're on the phone with us today during your lunchtime. So thank you very much for joining us. I'm going to go to that chat pad. It looks like we have 3 questions from Patricia. So the first question is where the funding comes for the E3 work. And our funding is from a grant from the United States Environmental Protection Agency. So what they've done is funded money to Penn Tap, and our job is to go work with the companies on E3 and find partners like NEPERC to work with it. Another question that just came in was working with the Manufacturing Extension Program partnership, which NEPERC is a part of. Pennsylvania just does it a little differently with the naming structure. So that's our job, and then we give those services of both PennTAP's role and the continuous improvement experts role free to the company we're working with. So they're able to get this service, our expertise, for free as long as they commit with us to do certain things. One of them is that we ask that the students come along, that they provide the information afterwards, and that we publicize some information with us. That another one of the questions was about how often do we have NDAs with companies? For E3 specifically, I do not think we've had to sign an NDA with any of them so far. On our general energy audit work, we have worked with companies under NDAs previously. Usually they're not a terribly difficult challenge. Luckily, I think for myself at least, Penn State has a thorough NDA process. So if I follow that process, generally everything works out well. We have worked with companies that don't require us to sign an NDA, but when we've asked to publicize some of their data, they've asked us not to mention their name, and that can be from a whole host of reasons, whether it's they don't want their competitors to find out. We even had one group that didn't want the people for the ethical treatment of animals to know too much about their location. So we've said if you don't want us to mention your name, we won't mention your name, but that's as far as we've had to go. There's a question about how do we get company buy-in for places to complete implementation changes in 90 days. Jerry, I'm going to unmute you for this, but I'm going to take control of it for a stab at it for first, and then I'll let you answer. That I think one of the beauties of this process is that you have the plant managers, the operators on the line, and support people all within a room talking about these improvements. And so from what I've seen, you have people who are dedicated and committed to making these improvements within that room discussing them. So really, they're part of their own idea to begin with. When you have someone who's, say, the plant director or plant manager in the room, seeing that there's an idea of, say, one thing we had really simple was adding a 5-minute break to certain employees will actually create a trickle-down effect of improved efficiency. People are much more likely to come in and do that change. We have basically have the decision makers in that room so that they see the whole thought process behind it, and they're much more likely to make that quick change. Unfortunately, some things fall by the wayside, especially if you have money involved, but I think the team approach is really the key to help get them with that buy-in. Jerry, did you have anything else you'd want to add there?
The only thing I'd like to add is that quite often, sometimes people want to take on too large a project that just isn't fully vetted in that 3-day period. So typically what we like to do is break that into incremental improvements, and incremental improvements in a size factor for those things that maybe could get solved in that 90-day period. And then I think management has a much easier approval process for going forward with that. And also, it also gives us if we target those shorter improvement projects, it gives us that safety net just in case we're going down the wrong path, so that we don't get so invested in a large initiative that sometimes it's hard to back up. So this gives us that ability. It's not quite single variable experiments, but we like to get them as small as possible so that we're not shotgunning the impact, that we're actually able to measure direct improvements based on that one action. So again, we also have a parking lot that we create, which are for those larger ideas that just make sense, but that really they need to be handled outside this value stream mapping process, not forgotten, but just handled in a different way, maybe as a major project rather than as just improvement action items. And that's about all.
Okay. And then we also had a question from Lionel about funding for P2 grant or E3 grants. PennTAP has funding that we are able to help with E3 projects as well as P2 projects from the US EPA. So we'd be able to do those free of cost for manufacturers. And then we work with a different state agency that we have energy audits available that we could work with. So if anyone on here is interested, please feel free to reach out to me afterwards and we can discuss in a little bit more detail. So that is all the questions in here right now. With that, I'm going to stay on the line for another 3 to 4 minutes. But again, thank you all very much for attending. If there are no more questions, I'll wind up closing down the webinar. Thank you so much for your time. And again, if you have any questions at a later date, feel free to send myself or Jerry an email asking those questions. Thank you and have a great rest of your day. Okay, thank you all for attending, and please reach out if you have any questions. Have a great rest of your day.